A direct variation between two variables, y and x, is a relationship expressed as y equals kx, where the variable k is called the constant of proportionality. In most problems, the k value needs to be found using the first set of data given.
Hey, Dr. Kepner, what do we have right here?
Well, Dr. Gray, we have some broken ribs, and I'm trying to figure out the formula in order to carry on with this procedure.
Well, if we directly variate ribs C and J, then we can get this patient up and moving.
Okay, so if rib C varies directly with rib J, then we just have to find the constant proportionality, and then that'll be enough to get her ribs back together.
So C equals K times J.
Okay, that works. And then this is 18 millimeters, and her
The
rib
split
J
rib is 9.
Yeah. Okay. Well, let's get to the operating room.
All right.
Okay, so we know that rib C is varying directly with rib J, and rib C is 18 millimeters, and rib J is 9 millimeters across, and we know we need to find what this equals, but we also know that this equals 20 millimeters, because then we need to find this one after we find the first proportion in order to realign her ribs. So, for the first part, we have C equals K varying directly with J. So C is 18, and K is the constant proportionality which we need to find. J is 9, and then do the basic algebra, divide by 9, divide by 9, so K equals 2. So now we have K to plug back in while we use 20. So now we have D, so D is 20, and we now have K, which is 2, but we need to find L. So again, we are going to divide by 2, and L is going to be equal to 10. So now we have all measurements of the rib cage we need in order to carry on with the procedure. Now if I didn't have L, or if I didn't have D, but I had L, then I would have filled in 2 and 10 and multiplied that to 20 and gotten D as 20, so you can find all measurements. An inverse variation between two variables y and x is a relationship that is expressed as y equals k over x. In an inverse variation, the values of the two variables change in an opposite manner. As one value increases, the other decreases.
You called?
Yes, we have another case. So for this one, I think we're going to have to use an inverse variation. So y has to vary inversely with x, and we need the constant proportionality for k.
Okay, so in order to do that, to remove this tumor, y has to equal k over x. That way we can find k and are able to find the area to remove the tumor.
Okay. Give this tumor out, it'd be a miracle.
Okay, so we know that y is equal to 15, and x is equal to 3, and b is equal to 8, and this is going to be r. So y, we said, is varying inversely with x. So, now that we have our formula, we're going to plug in our numbers. So 15 equals k over x, and x is 3. So now you do the algebra in order to figure out k and get it by itself. So you multiply each side by 3. 15 times 3 is 45. So now that we have k, we need to find r for this side of our brain tumor. So we have b, and b is 8, and our k is now 45, and then we need to find r. So to get r by itself, you still multiply by each side. So r is going to equal 360. So now we have all of our values, and this formula is going to prevent us from hitting any vital nerves, so we do not cause long-term brain damage. Sometimes more than one variable is involved in a direct variation problem. In these cases, the problem is referred to as a joint variation. The formula remains the same with an additional variable included. The formula is y equals xkt.
Sorry, Dr. Kepner. I just got out of the OR with some brain tumors.
That's good, because you have another one.
Oh, shucks.
So, now we have brain damage and some fluid in the brain.
Yeah.
So, I found one formula to fix all of our problems, and we can do it all at once. So, I figured if we took the first brain scan as y, varied it directly with the second brain scan, which would be x, and then jointly with the third brain scan, which would be t, and this one I measured to 35, this one was 7, and this one was 5 of the amount of damage. So if we did that all at once and plugged it in, I think we could get it all in one sitting and cause them to not have long-term damage.
Good job, Dr. Kepner. So we got a case of the y equals kxt.
3, 2, 1.
Okay, so this has a measurement of 35. This measurement is 7, and this measurement is 5. We need to find the measurement of S. So, our formula is y equals k x t. Okay, so we have y, and y equals 35. We do not have a k. We have an x, which is 7, and a t, which is 5. Now, you multiply these two, so it's 7 times 5, which is 35. So you have 35 equals k 35. Divide each side by 35, so k is equal to 1. Now you have your k, so we need to find our s. So our formula would be s equals 1 times x is 7, and t is 5. Ooh. So you do 1 times 7 times 5. So S is also 35. And so that is what we have to work with in order to get the brain fluid out. And we know to not cause brain damage by our numbers. So we got this by finding the constant proportionality, which is k. And then we have our joint variation.